Hello, welcome to lesson 4. Okay, first thing to do is to read these directions, and I know these directions are a little bit hard to follow sometimes, but read them carefully. So it says for number 1, the total length of each tape diagram represents 1. Okay, so each of these tape diagrams below is 1. Decompose the shaded unit fractions. The shaded unit fractions decompose again means break apart. Decompose the shaded unit fractions as the sum of smaller unit fractions in at least 2 different ways. The first one's been done for you. So this first one, A, is just for us to look at. So we've got a half shaded, and they broke this half. They drew some extra lines in here. So now we have 1, 2, 3, 4. We have fourths, and they're saying a fourth plus a fourth is a half. And you might be saying, but wait, when you add fractions, the denominator stays the same. You could also say that it's 2/4, and then we divided them both by 2 to get back to 1/2. The other one, it's still a half, because remember we're doing it in at least 2 different ways. And this time they have broken the half into 4 pieces instead of 2 pieces. And they went the whole way. So we could again count 1, 2, 3, 4, 5, 6, 7, 8. That's why these are all eighths. This equals 4/8, 4/8, which if we divide them by 4/4 comes back to 1/2. So that's what we're doing all the way through. So B, we've got a third, and they've broken the third into more pieces. So altogether, this is 1, 2, 3, 4, 5, 6 jumps. So these must be sixths. A sixth plus a sixth equals 2/6. And of course, if we divide these both by 2, we get back to that 1/3 that we started with. Here's 1/3 again. This time they broke the third into 4 pieces. And if we jump all the way down, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That's how I know these are twelfths. Altogether that is 4/12. Let me see if I divide this one by 4/4, I get back to 1/3. So 4/12 is the same as 1/3. Now it gets a little bit tougher because we have to do it ourselves. So first I'm going to look at this shaded one and see, like, there are 1, 2, 3, 4 jumps. So this must be a fourth. And I need to break this up somehow differently. So what if I just break each part in half? And now I've got 1, 2, 3, 4, 5, 6, 7, 8. So these are eighths. Equals 2/8. Divided by 2/2, and that equals 1/4. So 2/8 is the same as 1/4. Now we have to do it a different way. Still, this is 1/4, but we have to divide it into a different way, not eighths this time. So what if I did this into 3 sections each? Now I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. These are twelfths. 1/12 plus a 1/12 plus 1/12 is 3/12. Divided by 3/3 gets us back to 1/4, so 3/12 is the same as 1/4. Now we've done 1/4 into 2 different unit fraction sums. Okay, D. Let's see. 1, 2, 3, 4, 5. So these are fifths. The other one's going to be the same. It's still fifths. So the easiest thing to do is just break these in half. And by now, hopefully you're noticing the pattern that when we break the fifths in half, it makes these be tenths, right? We're going to have twice as many jumps. So a tenth plus a tenth equals 2/10, which is equivalent to 1/5. And let's see, I'm going to break it. What if I broke this into 4 pieces? And of course, this is up to you how you broke this up, as long as your sentence matches. So if you broke these up different ways, that is all right. So I broke this one, each of these fifths, into 4 pieces, which means I now have 20 different pieces. So these are 20ths. So a 20th plus a, whoops, that's not a 20th. A 20th plus a 20th plus one more 20th equals 4 20ths, which is equivalent to 1/5. Okay, number 2, we have new set of directions. The total length of each tape diagram represents 1, so the whole thing is always going to be 1. Decompose the shaded fractions as the sum of smaller unit fractions in at least 2 different ways. Well, it sounds like we're still doing about the same thing. I guess the difference is we don't have a unit fraction that they shaded. So for A, there are 1, 2, 3 jumps in one, so these are thirds, but there's 2 shaded, so 2/3. And again, we're going to break it up. So if I did have thirds, now I've got 1, 2, 3, 4, 5, 6. I've got sixths. Equals a total of 4/6, which is equivalent to 2/3. This one over here is still 2/3. We need to find a different way to break it up. How about breaking each of those thirds into 3 new pieces, which would be 1, 2, 3, 4, 5, 6, 7, 8, 9. A ninth plus 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 1/9. Altogether, that is 6/9, which should be equivalent to 2/3. All right, part B, we have broken this one into 1, 2, 3, 4, 5. These are fifths, but 3 of the 5 are shaded. So we're looking at 3/5. We have to break it into smaller fractions. I broke these in half, and which means I've doubled the number of pieces, so I've doubled my denominator, so these are all now tenths. Four, 5, 6/10, which is equivalent to 3/5. You can do the divide 2/2 together. Okay, now 3/5 divided up some other way. Do the 3 pieces. If I do any more pieces, I won't have room to write down the fractions. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 pieces. Makes sense because I did have fifths and I broke them all into 3 pieces. So 3 times as many as 5 is 15. 1/15. I think the hardest thing about this is writing all the fractions. There's 3 of my 15ths. More 15ths. Altogether, I think I'm going to need 9 of these 15ths. 1, 2, 3, 4, 5, 6, 7, 8. One more. And 9/15 divided by 3/3 equals 3/5. So it is equivalent to 3/5. Okay, we are on to number 3. Draw and label the tape diagrams to prove the following statements. Okay, so we were just proving what they have already said. So for A, they said 2/5 is equal to 4/10. On the top, they've labeled it 2/5, which makes sense because there are 1, 2, 3, 4, 5 sections, and they've shaded 2. And then they did the extra sections, and 4/10 takes up the same amount of space as 2/5. Okay, so we have to draw a tape diagram for 2/6 down here on the bottom. So I need 1, 2, 3, 4, 5, 6 sections. I'm going to shade 2 of them. So the top one is 2/6. If I break this up a different way, let's see. If I double it, yep, doubling it's going to get 12, right? Now I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. These are 12ths. Looks like I've shaded 4 of them. So that does match what they are saying, that 2/6 is 4/12, and I have a picture to prove it. C, we are doing the same thing. We need a tape diagram showing 3/4. 1, 2, 3, 4. We're shading 3 of them. We need to make it be 6/8. You see, 8 is twice as big as 4, so there's going to be twice as many of them. I forgot to label my thing on top. 3/4. And below I've got 6/8, right? 1, 2, 3, 4, 5, 6 out of the 8. Yep, that proves that they are the same. Oh, we get to do 3/4 again. Yay, that's easy to draw. So 1/4, 2/4, 3/4, and 4/4. Shade 3 of them. We have to make this be 12ths. So I can't just do them in half because that would give me 8ths. But if I did 3 for every one of these sections, that would give me a total of 12, right? So now I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12ths is what I wanted. And I do have 1, 2, 3, 4, 5, 6, 7, 8, 9 shaded. So this picture also proves that 3/4 is the same as 9/12. Number 4, we have to show half is equivalent to 4/8 using a tape diagram and a number sentence. Okay. So here we go. Here is a half. And we need to make this be 8ths. So let's see, if I do that, that would be 4ths. If I do it again, I can have 8ths. So now we've shown that 1/2 is the same as 4/8, but we also need a number sentence. So let's see, 4 times 1/8 equals 4/8. If we divide that by 4 over 4, we get